Good morning, everyone. Welcome to the wastewater stream room. First session today is, oh, sorry, I don't know if I'm hearing my own feedback. First session today is Ben Kineshanko from the District of Squamish, and he is presenting on the Queensway lift station inlet maintenance hole failure, emergency response and recovery. Ben presented on this last year, so I know I'm very eager to hear about the update. Ben is the Utilities Manager for the District of Squamish Public Works Department and a Board Director at the EOCP. He is a certified water and wastewater operator, an applied science technologist, and an environmental professional. Ben has a degree and diploma in environmental engineering technology and has spent almost 20 years studying, working, and volunteering in the water, wastewater, and environmental fields at both public and private organizations. Please welcome Ben.
Thanks, Natasha. Welcome, everyone. That was a wonderful intro, so I don't think I need to touch on that. As Natasha mentioned, what I'm presenting today is kind of a rerun of last year's presentation, and I wanted to talk about it because last year we weren't done. We were still in the middle of our recovery operation for this infrastructure failure, and I thought it was prudent to kind of finish the story. So if anybody, I'll apologize in advance to anybody who went through this with me last year, because some of it's a bit of a repeat and maybe refresh. So a little about my community first. So the District of Squamish was built on forestry. Historically, there was a big wood fiber pulp and paper was one of the major employers in town. It operated for 94 years. And during its heyday, whole families lived, worked, and were partially educated on site. I've met people in town that were actually born at the wood fiber site. When it closed, there was pretty severe economic depression in the 80s, 90s, and early 2000s, owing to the boom and bust nature of forestry. And the mill finally shut down in 2006. Since the Olympics, Squamish has kind of been reborn as a world-class seaside mountain town, known worldwide as a destination adventure community. As such, the district's undergone significant growth in the past decade, and anybody who's driven a Whistler, in the past 10 years should have noticed. And that's expected to continue. We're the subject of several up-and-coming high-profile developments, including the wood fiber LNG facility that's just begun construction. There's also a resort proposed on Brome Ridge, just below Diamond Head. That one's kind of up in the air now, but it's been hanging out there for a lot of years. And then a new one lately is a Capilano suspension bridge style attraction, actually quite near our water source. And I don't know if anyone's been on Instagram lately. Mamquam Falls has become pretty insta-famous, and it's wild because when we drive out to our water source, it used to just be forestry trucks and us really, and nowadays, it's a dirt Forest Service road that you'd find anywhere in BC, and there's Teslas and Ferraris and all these crazy cars driving up just to get a look at these falls. So it's been interesting. And then additionally, there's actually a housing development and landlocked surf resort proposed, and I believe approved for Britannia Beach as well. So as with many other communities in the province, growth is straining the capacity of our aging infrastructure. We didn't have a lot of money, the last 50 years to invest in infrastructure renewal, so it's really starting to show, in my opinion. In this case, we were the victim of severe H2S corrosion, kind of rapid community growth, creating a perfect storm. So a little bit more about Squamish. So 2023, we were around 25,000. It really depends who you ask, and I find the stats are changing year to year. I'd say we're anywhere between 25 and 30,000 now, based on illegal suites and people living out of vans and everything else that goes on in town. We're a Class 3 water supply and distribution facility, Class 3 wastewater collection. We've got 27 lift stations, so one per probably 1,000 people, which is pretty high numbers in my estimation. It's a lot of infrastructure to maintain. It's kind of owing to the fact that the community is really spread out and quite flat in certain areas, despite the fact that we've got mountains all around us. And then we're a Class 3 EOCP treatment facility, secondary biological treatment with UV disinfection. We have an ongoing upgrade right now, $20 million upgrade to add a circular new combined treatment unit and turn some old tanks into primary clarifiers. So we will be a Class 4 facility probably in another year or two. So another challenge to overcome. Speaking a little bit about the Queensway lift station, so it's the largest lift station in the district. All of the flow from the Valley Cliff area and then everything south of the Mamquam River, including downtown Squamish, flows either to the central lift station to be pumped to Queensway or to Queensway directly by gravity. So approximately a third to a half of our average dry weather flow flows through this system. And this manhole, it was kind of the linchpin to it all. So it was a single 1050 concrete unlined manhole receiving force main flow and gravity flow right before it entered the lift station. And I think it was one of those things where we had an old treatment plant downtown. It was decommissioned, and the easy solution was to pipe it north. So they plugged a HDPE force main into an existing manhole without doing any further upgrades to save cost. In a period, and then that was done in 2006. So in a period of less than 20 years, we saw a significant failure because of that. A little bit of background, we kind of tweaked that there might be a problem in 2016. We did an odor audit on the community. We kind of looked at all of our lift stations, our wastewater treatment plant, where odor impacts were, and it was through an organization called Odotech. I think they've since changed names, but they were the ones that kind of educated us and informed us that we had H2S problems in certain areas. After that came a sanitary master plan, and out of that master plan, a lift station condition assessment report that identified quite a few issues around our collection system, Queensway being one of the major lift stations that it called out. And then, as we all know, we had a pandemic in there. And there was a lot of impacts that went on, and I think we're still feeling the effects of supply chain delays, human resource challenges, all that fun stuff, and then the costs increases that went along with it. And then between 2021, kind of during the pandemic, we were working on replacement and repair design and construction plans for that lift station. Just another little bit on the timeline. So a tender went out in 2021, and it had to be canceled because the tender results we got back during that time when inflation was going crazy were double what we budgeted. So it was rebudgeted for the following year, put out, had to be canceled for the same reason. It doubled, the cost to do the project doubled twice in 2 years. So we thought we had it licked, and then we didn't. And then in 2023, it was tendered a third time with increased funding, and the closing date, just keep an eye on that date, was February 10th. we would have been signing a contractor on to do some replacement and upgrade works. But on January 9th, this happened. So it was a Saturday morning, and I got a call from our utility supervisor saying, oh, there's a sinkhole. What do you mean there's a sinkhole? Well, this is what we found. So we immediately engaged a geotechnical engineer to help us keep crews safe, working around the ever-changing conditions, because it was kind of sloughing as time went. Obviously, we've got most of the communities, or a large part of the community's flow going through this manhole with no bypass. So we just kind of had to keep on keeping on. Immediately, we had kind of hoped to be able to, fill the holes that were created. Essentially, what happened is at the bottom of the 6-meter deep manhole, the bottom couple rings started failing. So basically, everything outside of that manhole, the debris, the sand, the cobbles started flowing into our waste stream. And because the groundwater table was really high, it was liquefied soil. So it was flowing rather than reeling or rolling. So we immediately started plans to install an emergency bypass. We went about finding and organizing 4 different contractors to install the appropriate piping, valving, hot taps, and to do the vacuum and tanker shuttles that we knew would be needed from downtown so that we could basically shut down long enough to install the bypass. Key goals were to keep staff safe, support the manhole, slow down or stop the leak, prevent complete failure, and construct a temporary bypass in case it did fail. In the one picture there, we've got one of our operators holding we didn't have a camera that we could kind of turn and rotate, so we came up with a Bluetooth GoPro and a Pelican light strapped to a PVC pole as an investigative tool. So then we had all of, where are we here? Bypass preparation and planning, right? So we did our locates, our BC1 call, had our hot tap and bypass contractors kind of lined up. We recruited an engineering firm to model what kind of flows we would get through a temporary bypass, so we knew if we could handle wet weather events. And we were all kind of set to go for the evening of January 13th to do this work, hoping to avoid further issues. And then this is what we woke up to the morning of January 14th. So the manhole collapsed catastrophically. Sinkhole got much larger almost immediately. And this is just a note, a text from our chief operator who was just happened to be getting on a flight to Mexico that morning. So, his words of wisdom were, you have 3 hours, referencing the time we had to respond and come up with a solution before all of downtown Squamish was fully surcharged with sewage, which is a very, very flat, shallow system, which could impact thousands and thousands of residents. So we didn't have a whole lot of time at this point to respond. So the photo here is the excavator bucket being used to prop up the manhole to keep it from falling over entirely. By the evening, this is what it looked like. So the manhole did ultimately fail. About 14 hours before we were scheduled to install an emergency bypass. Truckloads of liquefied sand and gravel flowed into the lift station. We were still amazingly able to convey flow just basically through the open ditch into the lift station and onto the wastewater treatment plant for a short period of time. Of course, it happened during the highest flow period of the day, as you would expect. And all of downtown at this point was effectively cut off from the wastewater treatment plant. And the photo here illustrates the groundwater level at the lift station at the time. So well above where the inlet to the wet well is. some examples of impacted downstream infrastructure. So these are our fine screens at the plant. You can see there next to my millwright friend that there's some pretty good bent up lamellas on those fine screens. And then you've got a picture of the impeller from Queensway lift station, and then photo of the grit and gravel that was built up in our grit separators at the wastewater treatment plant. So it flowed through the lift station pumps, through the force main, right into our influent gallery at our wastewater treatment plant. And I mentioned that's our largest lift station. We have 4 60 horsepower pumps there. And they all got banged up pretty good. So we obviously went into emergency response mode right away. Myself and our Director of Public Works turns as incident commander. We had to designate 3 sites to manage because we had our lift station downtown, we had the site where the failure happened, and then we had the wastewater treatment plant to deal with. Main priorities for the response basically initially was to gain situational awareness, obviously work safely, mobilize staff and contractors to reestablish conveyance and treatment capacity, and manage traffic impacts through the industrial park. So some of the good, all of our contractors were scheduled, for later that day to respond, to build the bypass, and we kind of had a lot of the pre-planning work done for that. One of the unfortunate things, though, is because they were due to work all night that night, they were actually they had stayed up late the night before and were sleeping. So mainly all of them had to be dragged out of bed to respond earlier so that we could get started. So they were starting sort of on no sleep. We called out basically all of the public works staff, including former staff members who were still casuals with us. Some came from Metro Vancouver, some came from Whistler, as well as our engineering and environment, communications, emergency management, and senior leadership team. We had lots of help from local contractors. As I said in my presentation to council, we were borrowing and stealing from local contractors, and then I was corrected that we weren't stealing. So they council called me on that. So eventually the manhole obviously did clog completely. The EOC was active around midday, and as gravity mains were surcharging downtown, we realized that the vacuum trucks that were on their way weren't going to make it in time. So we reached out to the community we have a Squamish Alert app, so if you're signed up, our comms department can push notifications to people to stop using water. That's always a pretty delayed response. The comms team was critical, just communicating to the community, dealing with regular situation reports in the field and with contractors every few hours, and with contact information sharing. Unfortunately, because of the surcharging downtown, we did have to spill to the environment for about 6 hours, I think, before the vacuum trucks could get there and start shuttling flows. We were actually able, because we had a bypass port installed at the central lift station for pump bypassing and for pigging, we actually were able to use the station pumps to discharge to the environment, for better or worse. So if we hadn't have done that, literally thousands of homes would have been full of sewage downtown. We did flood parking garage and 1 residence, I believe, partially. Obviously, spill reporting was initiated, and ultimately, I'll skip that. So when the vacuum trucks finally did get there, they had to work through the night. So in total, we had 11 trucks running nonstop for over 16 hours while we were building the temporary bypass to convey wastewater out of that catchment to the wastewater treatment plant. And this was right in the middle of a residential area, so you had 3 trucks running flat out all night, and we had almost no complaints. It was shocking. So in the span of about 24 hours, 2 bypass systems were installed. at the lift station. One for gravity flows in the industrial park area, and then the other one, which is the thing of beauty on the right-hand side there, was what we put together to convey force main flows around the manhole and into an existing bypass port that we had at the lift station. Obviously not designed for wet weather flow. This happened in January. Had we had, big rains after this, we would have been in a world of hurt again, but luckily we had a pretty dry year that year. So some of the issues, obviously requiring regular staff involvement. For the gravity side of it, we were able to get pumps that came with a float system, and we were actually able to tie them into the hydro off of the building, so we didn't have to run diesel pumps nonstop. It took several weeks to get to that point, but it definitely helped reduce our rental and fuel costs and greenhouse gas emissions. And lots of innovative methods and materials used in construction. I was very proud of staff for what they came up with that bypass, and to do it in such a short period of time. I believe our director might have even been out there swinging the wrench. Don't tell anybody. Why did all of this happen? Some of you may know, some may not. So hydrogen sulfide production occurs in sewer systems in the absence of oxygen. So bacteria growing in the pipe walls consume oxygen preferentially. Once it's depleted, they switch their metabolic pathway and use sulfur in the form of sulfate or sulfide for respiration. This creates an environment where hydrogen sulfide and sulfuric acid are created as a byproduct of cell respiration. That is obviously something that attacks and corrodes concrete and metal. Concrete on the bottom of the manhole and below the water table corroded to the point where hydraulic pressure from the outside pushed through the concrete structure and allowed groundwater and sediment to enter. So recovery plan, this was the slide I shared in September of last year. So we had, as of this time last year, we had designed new influent manholes based on work we had been doing that was in stream for the tender process. We actually ended up going through 3 engineering consultants before we finally completed the project. So we had repaired pumps and treatment plant equipment, but we hadn't done any of the relining, recommissioning, or cleaning of the force main. So this is where we are today. We've built new influent manholes, repaired the pumps, obviously, relined the lift station, recommissioned the lift station, and we also inspected or pigged and then inspected the force main using a piper's ball. So this is some of the work that had to happen to replace the manholes. So they had to do quite a bit of shoring and sheet piling. They actually had to do this twice because they were having issues with groundwater intrusion, and they put, Natasha, help me if I need it, essentially a survey point on the foundation of the building, and they found as they were driving the sheet piling that we were actually getting some settlement in and around the lift station wet well. So they had to do it as gently as possible. And then obviously there's a dewatering setup there as well to keep the groundwater out. And what do you do with all that water? Even in dry weather, the downstream drainage ponds were backing up due to freshet in the Squamish River. So we had to split flows to an alternate storm catchment. Lots of diesel pumping. There was a washout and failure of some improperly installed storm culverts downstream due to the sustained high flows. We had environmental consultants engaged to monitor ongoing water quality risk. and some real challenges because we found that there was some iron in the groundwater that we were removing and had to deal with that. Bi-weekly sampling at various points along the discharge paths, and obviously notifications to the Ministry of Environment and DFO. So basically through significant investigation, it was determined that the discharge was not deleterious to the environment, but we had to jump through all those hurdles to prove that, right? There was lots of utility conflicts, so that interesting contraption there is an I-beam with some come-alongs on it that is holding up a hydro vault. So we had to figure out how to keep that infrastructure online. Ultimately, it had to be relocated and removed, so we had to work with hydro on that just so that they could complete installation of the sheet piling. Alternate measures, you had to do a 922 for this one, I think. The contractor was required to verify their isolation procedures because they had to make sure the wet well was isolated from the pumping bypass that we had set up. So they had to add additional valving to make space for the work. We had to do a number of force main shutdowns, and I think in total we redid the bypass 3 times, or certain segments of it 3 times, just to deal with the alternative measures side of it. This was some of the debris that was inside the lift station. So you can see the large, football-sized cobbles that came into the wet well, and some of the debris that was removed. And this is what we found inside of the wet well, which wasn't entirely unknown to us. We had done a condition assessment, and we sort of expected to see things, but once you get it all cleaned off, it always stands out a little bit more. Interestingly, on the top right corner there, that's a check valve body that had sprung a leak. So it had a pinhole right through the check valve body. But it was quite stark, the contrast between the operating water level, the areas that were completely submerged most of the time versus what was exposed to air. So you could see where that hydrogen sulfide gas was contacting water droplets on the wall of the lift station and degrading the concrete. Some photos of the exposed rebar. So the concrete had degraded far enough to expose rebar. Next steps, so restoration and relining. So obviously had to remove all of the H2S impacted concrete. They had actually done core samples previously, so we kind of knew how far back we would have to go to get to good concrete before it could be rebuilt. They had to protect the concrete and rebar, regrout the lost material, and then we went with a liner called a stray cat liner. We looked at FRP panels and or just leaving it concrete, and we wound up with a kind of a spray-on, paint-on PVC infused liner just to save some cost. And then obviously replacing piping with stainless steel, epoxy, FRP, anything that won't be corroded by H2S. So that's a photo of some of the recoating of rebar. Working on regrouting and installing that PVC infused liner. And that is sort of what the final product looks like today. So lots of shiny stainless steel, PVC, FRP, and that beautiful liner that hopefully will last us 40 years. Interesting, this lift station is well oversized for our flows, so we don't, our growth plan doesn't require replacing the wet well, so it was pretty key that we, kind of built for longevity. And then on the manhole replacement side of this was our design, so we took that, instead of a 1050 manhole, we went to 2 much larger manholes, one for gravity, one for the force main, just to kind of try to keep them separate. we had to regrade the main from the gravity manhole back to the next nearest manhole because of settlement during the sheet piling. So again, that was another 6-meter deep excavation with serious groundwater intrusion. And there was a vortex that we put inside the force main manhole. So the idea with this, I believe, is to strip H2S from the liquid as it comes into the station. One of the challenges we're finding now is that there's actually much higher concentrations of H2S gas within that manhole. It's not making it into the lift station, so in theory it's doing its job, but I'm curious to see how well that PVC liner holds up over time. And we installed some gate valves in the gravity manhole just to give us some flexibility for future upgrades if needed. So we kind of took the opportunity there. This is a video. Spirals around that structure at the top and then drops down a tube inside, and there's a bell at the bottom that allows it to flow off kind of in a more laminar manner. And service was restored to the station 14 months later. So the complete failure happened on the 14th of January 2023, and we put it back into service on March 22nd of this year. Total response and recovery cost was $6.15 million. So on the response side, our 2022 and 2023 budgets for this station combined are about $100,000, and our 2022-2023 actuals were more like $500,000. So that's a $423,000 variance there that we had to account for. And then on the capital side, the original tendered budget was $1.7 million, and the actual cost ended up being $5.62 million to restore that station. So again, another $3.8 million that our engineering department had to come up with and our finance department had to come up with to cover those costs. So some of the lessons learned, when your operators bring concerns to you, it behooves you to pay attention. Don't underestimate the impact of H2S corrosion. I know there's a lot of places in Metro and the bigger cities that have long force mains that experience similar issues. Conduct regular condition assessments of your infrastructure, not just lift stations. You know, everything you own should be looked at, you know, on some, 5 or 10 year recurrence period, just to see how it's holding up. And then accurate budgeting and costs. You know, we missed the mark on our budgeting on the capital side, miserably. And, that was during a pandemic and there was lots of other things going on, but it just, we failed to see how much of an impact it was going to make to our financials. And then, one of the things I really try to impress upon our financial people is to make sure you're putting away money into reserves and building contingency into our budgets. One of the things our engineering department has been doing is pooling their capital funding. So instead of having individual capital project-based budgets, like this money for this lift station, this money for force main, this money for gravity main, they just have one big capital budget for the year. And it allows you, if one project's not going so well or it's hitting roadblocks and another project is making headway but the costs are maybe more than you expect, you can funnel that money without having to go back to council for approval. Understand your system, obviously talk to operators. Scrutinize public complaints. If people are complaining about odor in an area, go and find out why. Is it the estuary that you're next to, or is it something going on with your lift station? We've started implementing H2S monitoring in our SCADA system so that we can see live trending, what's going on in this system, and identify areas where corrosion is happening and plan to mitigate sooner than later. I see Natasha's giving me the 5-minute warning and I want to leave time for questions. So we talked a little bit about drop structures. Chemical dosing is kind of one of our next things to pursue, is to try to reduce concentrations. of H2S that are making it to that lift station and then through to the plant. So, you know, you can use extraction fans and odor control processes. Again, they're costly and require maintenance. But I think most importantly is build these structures to withstand H2S and acid. You know, use PVC and FRP and all these things that we learned about that burn and cause other problems, but it helps protect your infrastructure from major failure. And that's it. Thank you. We had so much support from our staff, local contractors, our suppliers. You know, Flowcore rushed parts to us, no questions asked. Our residents were very understanding, thankfully, and neighboring municipalities helped out as well. Are there any questions?
So we do have one question from the online operators. First of all, he says, fantastic job, Ben, and great work to all your operators during this time. What H2S monitors are you using for SCADA application?
Boy, I don't know off the top of my head. I talked to a gentleman at the trade show yesterday that our chief operator has been dealing with. I think it was Procon was the company. So it's essentially an element that can be put in the environment and connected to SCADA that'll give you a readout. The one thing about those elements, though, is that they only last for, well, up to 2 years, kind of depending on the concentration of H2S. And there's another set of data loggers that we've used often called Odo logs. And they're kind of a portable battery-operated data logger that you can drop into really any space to be able to record H2S levels. So they're handy because you can kind of take them throughout your system, drop them in, bring them back to the office, and download the data.
Any other questions in the room? None online?
Rena from online, those gate valves in the manhole, did WorkSafe allow for this? Did WorkSafe allow for this for your alternative measures? If so, that is a great opportunity.
So it was a third-party contractor who had to do the alternative measures as they were the ones entering the space. I believe we had essentially a double block and bleed set up on the pressure side where the force main bypass was, and then at that manhole, because it's under gravity, I believe they would have needed alternative measures to enter it or WorkSafe authorization. But you're dealing with a non-forced environment there, so it's a little bit different than having a pressure pipe. So that manhole was placed after or during relining and reconstruction of the lift station. So they wouldn't have actually existed while we were in the lift station. Oh, thank you. Thank you so much. Hope I don't have to come back. The next one will be what you do when someone drives a grounding rod through your pumping water main.
Oh.
Under a 30-meter rock stack retaining wall.
Are you still finding the solution to that?
No, we've already solved that problem. Yeah, lots of fun with construction and development.
All right, if there's no more questions, yeah, thank you, Ben.
Thank you.
And then our next session's in 15 minutes.